Hello everyone, this is going to be a very quick video on the project which I've been working in the past 1 week. It's a solar generator, well designed and built to withstand a lot of capacity. Here I started by buying a strong DeWatt 2 bus. The 2 bus is about 29 gallons. I brought in from Home Depot. The system is designed to be 300,000 watts pure sine wave low frequency inverter and 24 volt system. The batteries are 8 cells, nominal 3.2 volt, 200 Ah. Lithium iron phosphate. Those batteries are new, and I tested the capacity before building it. I did a bottom balancing and everything worked very well. Then here you can see it's a nice system, quite heavy. I like the bus. In fact, as a matter of fact, the bus is very strong. You can stand on it. You can, use it as a ladder. You can sit down on it. Very strong bus. I love the bus. And again, the bus has wheels. You can, move it around. It's very mobile. You can take it to anywhere. I mean, the bus is fantastic. Here, the system has safety features. I put a lot of safety features in place as well, because I have breakers, I have fuses, I have right gauge wires, and all the wires I use are pure copper. Here, I will show you a little thing. Okay, look closer at the system. Here I have, on the right hand side, I have my charging stations. I have a USB port here. I have another USB port here, and I have 12 volts cigarette port here. So this charging station here can be turned on with this little switch here. Down here will give you the switch. This can be, you can use this to charge two USB, and this shows my voltage coming out. On the center part, this is the remote for the inverter. This remote is the same screen the inverter have, because I don't want to be accessing the inverter from when I can access the inverter when the system is closed. So I needed to buy a good inverter with a good remote system, which is programmable from outside, and you can set everything from outside as well. The screen of this inverter is the same thing. It is the same screen from for the remote. Here is the system turned on. Here I have a meter for my DC and for my AC output. This shows me, it's 16-1 meter. It shows me the current the voltage, the power going out, everything I'm drawing from the system. And here, this side is showing me this is MT50 for my solar charge controller. This is connected to my solar charge controller because I needed the MT50, because I can set the system from outside. I can set my solar charge controller, as well as seeing what is going on, how much solar is being put in, how much the battery status and the DC load status as well. Here I have a small meter which shows me how much left on my battery. Right now it's 100%, about 198 Ah. and like I said earlier on, my battery is 200 Ah lithium iron phosphate batteries, 8 cells in series. Here I have my solar input positive, my solar input negative. Actually, this is like a lock. You can you cannot, this cannot go on the other side. This can only go, the gray one can only go here and it cannot go here. So it's it has polarity. Let's turn the system on and see how. No, on the side I have here another cigarette charger, and I have a USB port. Here I can turn it off, I can turn it on. Even if you leave this USB, they don't draw a lot of current, and I mean they have switch and they can only be turned off. On the side here I have my AC output. I have two AC outputs. This is number one AC output, and this is another AC output on the side here. Here is another AC output. Here is my input, and this is a 30 amp socket. I have a fan here. This fan is intelligent fan. I have another fan here at the back, which is another intelligent fan. Let's turn the system on and see how it works. To turn the system on, just press the start button here. It says welcome to use. Then my meter will turn on. It's right now on an AC priority mode, and my input is 0. My battery is 26.5 volts, and my output is 239 volts. Here my AC is showing 242 volts out, and current 0, power 0, and here nothing is gonna show here. My battery meter is on and it's showing 198 amp hours. Right. So this inverter here, I can set everything. One of the good features of this inverter is it can charge lithium iron phosphate as well as other battery chemistries. On the side, on this inverter, I have, instead of buying, I bought on here, I have 220 amps Victron low voltage disconnect, but I didn't use it because this inverter can charge the battery as well. So putting the current in the reverse mode to that Victron will be to invert like a fire, and I don't want to do that. After contacting Victron, I found out that you cannot connect Victron on the reverse. They even said it in the manual. Here my battery voltage here is 26.6. my inverter is showing 26.5. my battery here is showing, my battery meter is showing 26.5. so they are, the difference is not much, despite the fact that they come from, they are that like different components. Right now I can use the AC. This system I designed it to work at 240 volts because I don't want to I needed to design one that will not be for American voltage. Actually, I don't intend to use it here. So looking at this, the system can be designed to be anything. I mean, you can see it's just simple, just getting the inverter that will give you 110 volts, 120 volts, instead of looking for the one that will give you 120, 220 to 240 volts. Looking at inside, here I have my connections, right gauge wires, right fuses, good battery, and the inverter. I have the inverter here. the same. You can see this is the same screen with the screen up the bus. Here I have my AC output. I have my AC input on this side. I have my AC input on this side. Then I have my DC blocks. Actually, because this system is designed to be a 24 volt system, but my DC outputs are 12 volt system, so I needed to get 40 amps converter, which converts the 24 volt to 12 volt system. And I have my inline here to the converter, 50 amp fuse, blade fuse, and I have fuses for my DC loads. I have two fans. Anytime, any day, if this system is hot, then these fans, they are intelligent fan. I have intelligent model here. This intelligent model makes this fan to operate only when the temperature increases. So I set the temperature to this system to turn the fan. I have fan 1 here, which has this probe on the side of the battery, and I have another fan here, another probe here close to the inverter. This is a second probe, which if this side is hot, then this fan here will turn on. If that side is hot, then it will turn, that fan over there will turn on. I have a negative shunt to the battery meter. On the negative shunts here, I have 1 gauge Y from my battery. I have 250 amp circuit breaker, which I didn't choose. I chose this circuit breaker because it serves to turn the whole system off as well. So if anything goes wrong, all I need to do is to press this, and the whole system is off. Here the whole system is off. This system is off. That system is off over here, and this system is off as well. So if I need to turn it on, all I need to do, I have a circuit breaker here. I will turn the circuit breaker, then I will be able to turn the inverter on. So, right, I have 40 amps for my charge control unit. I have 40 amps, which 40 amp solar charge controller, and fused with a 50 amp circuit breaker. And here I have a circuit breaker to the battery terminal, battery for charging with solar. I have 120 amps BMS, which is from Daly. They have good reputation and their BMS is good. Here I left this open. If I need to check what is going on the meter, I have battery go meter, which will show me the individual cells, if they are balanced. Actually, I did a bottom balancing, and I checked the batteries and they all work well. I have the battery secured here with a lock nut on behind, and screws with both to aluminum plates. Here I have, what else? 2 fuses. The inverter has a remote. This is the remote Y terminal to the remote. Is I think RS 482 thereabout. I will check. The system is well designed. It has good features and good safety features as well. The system has been tested and worked very, very good. I did a simulation with a solar, and see, I did a simulation here with a solar. I have benchtop. I have benchtop DC. I have my solar positive. This solar positive I have here. Okay, I have my solar negative. Okay, now I have solar in. Okay, this shows I have solar coming in, and just solar. This is just a little stimulation, and here my battery is blinking. It's already charged. It's already fully charged. So this system can be charged with two methods. This system can be charged with two methods. I can charge it with solar as well as the mains. So if I want to charge it with the mains, I have my socket, 30 amp socket. It's a twist cord. So once I plug it, it shows here the battery is blinking, charging, and it says in AC priority. I have 230 volts coming in. My battery is 26.5 volt, and output is 230 volt. If you look at here on the meter here, I have 228 volts coming in, going out, and 0. Okay, as you can see, my battery here is charging as well. It's blinking. That shows it's charging. Okay, so what else? To see if we have one moment. My heat gun is plugged on. So right now it shows I'm drawing how many watts? 654 watts. If I increase this, right now I'm drawing 1.24 kilowatts or 5 amps, 5.15 amps. On the inverter here, it shows I'm drawing only 32% load. So 21% load. You see, the system is good, well designed, has good features for safety, and I hope you will like it. If you do like this project, just give it a thumb up. Let me see what you think in the comment section.